All right, in this segment what we're going to do, we're going to look at two different types of problems that you can apply the Effectiveness-NTU method to, and with that we'll look at the procedures for each type of problem that you can apply it to. So the first type of problem we're going to look at is referred to as being the rating problem. And if you recall, this is the problem that we ran into some trouble with when we applied the LMTD. So typically you know the following information for this type of problem. And the unknowns, the heat transfer rate, and the exit temperature of our fluid streams. And consequently it becomes difficult to apply LMTD because you don't know the exit values and you have to do that iteration. So using the Effectiveness-NTU for this type of problem, we can go through a step-by-step procedure. And what I would recommend when you're solving these problems, don't necessarily adhere to these procedures exactly as I'm showing here. Sometimes it's a matter of using common sense, looking at what you have and what you don't have. And you're solving a bit of a puzzle when you're solving these problems, because every one can be a little tiny different or a slight difference from one problem to another. But that is just an example of procedures that you can use for solving these types of rating problems. So to begin with, you calculate the value of C min over C max, and we call that CR. And then we have our number of transfer units is UA divided by C min. And once you have that, you can determine epsilon, or the effectiveness, from the appropriate figure, if you have a figure in your book, or you can use an equation. Now remember, the equation is going to be the more accurate approach. Third step. The third step is you compute the heat transfer rate. And remember, we multiply that by the maximum temperature difference, which is the hot temperature N minus the cold temperature N. And with that, now that we've determined the heat transfer rate, then we can determine the outlet temperatures. Okay, so that's how you can go about solving a rating problem using the Effectiveness-NTU method. Now sometimes, depending on the nature of the problem, you can get a fun problem where you don't know which is the minimum fluid, and you have to guess that and then go through and try to solve it. And if the equations don't work out, that's a pretty good indication that you picked the wrong fluid as being the minimum problem. I'm not going to cover those, but you could have a problem that involves something like that. So that is a rating problem in the procedures. The other type is the one that we used or applied LMTD to, and that is just a sizing problem, but I'll go through that procedure as well. And so typically when you're dealing with a sizing problem, you know the following information. And what you're trying to find is quite often the surface area. You're sizing the heat exchanger. So, okay, so the procedure for a sizing problem, let's take a look at that. And the solution is going to depend upon if the hot fluid or the cold fluid has the minimum m dot c sub p value. But if the minimum fluid turns out to be the hot fluid, then your effectiveness is computed with the following equation. And if the minimum fluid turns out to be the cold fluid, then the effectiveness is determined with a different equation. Okay, second step, we determine the value of CR. Third step, so we know the effectiveness and we know CR. So with that, you can determine the number of transfer units, and you get that either from appropriate figures or equations. And again, as before, using the equations will yield more accurate results. And then finally, we're looking for the size. So knowing the number of transfer units, we can then get the area of the exchanger. Divided by the overall heat transfer coefficient U. So those are two different methodologies or procedures that you can use to apply Effectiveness-NTU. We looked at either a rating problem or a sizing problem. So what we're going to do in the next segment, which will be the last segment of this lecture as well as the last segment of this course, we're going to take a look at applying the Effectiveness-NTU to solving a heat exchanger problem.